So special right triangle, section 13 pre. Again, section that kind of to lead into chapter 13 and all the trig functions. Just some different things you have to recall from geometry, more or less. First thing I want to talk about is the 45, 45, 90 triangle theorem. Does everybody remember hearing about this in geometry? Probably spent some time on these. There's special rules. Okay, we're going to recognize those rules today. In a 45, 45, 90 triangle, both legs are congruent and the length of the hypotenuse is the square root of 2 times the length of the leg. 45, 45, 90 triangles are all about the relationship of the square root of 2. For instance, if my legs are 8, my hypotenuse is 8 square root of 2. If my legs are 23, my hypotenuse is 23 square root of 2. Notice, what's the relationship? Every time I'm multiplying by the square root of 2. I can make numerous numbers up here. Let's say instead of 23, I make this into 37. Well, what's my hypotenuse then? 37 square root of 2. Let's say I do the same thing. Let's say I make it up and said it's now 7. What's my hypotenuse? 7 square root of 2. Let's do another one. Let's say I have 111. What's my hypotenuse? 111 square root of 2. Notice, every time, okay, it is the relationship of the square root of 2. On your NISA test, they will give you the reference sheet that looks a lot like this diagram right here. And what do you have to notice? You have to notice the relationship is the square root of 2. Okay, so I can give you any number for the leg, and the hypotenuse is always times the square root of 2. But what happens if I go backwards? What happens if I tell you the hypotenuse now is 35 square root of 2? Well, what's my legs? 35. Again, recognize, if I give the hypotenuse now, I need to divide by the square root of 2, right? Well, that's great when I have the square root of 2. But what happens if I have a problem like this, where now it gives me 10? Okay. What's my relationship always? 45, 45, 90 is all about the square root of 2. So if I have the hypotenuse, I want to divide by, so really I get 10 over the square root of 2. Can I have a radical in the denominator? No, so what do we always do? We multiply by the square root of 2 over the square root of 2, right? So I get 10 square root of 2 over square root of 2 times square root of 2 is 2, because I get the square root of 4, which is 2. And then I simplify. What's 10 over 2? I get 5 square root of 2. Notice, every time I have an answer here, there is a square root of 2 somewhere in that answer. Okay? Again, the relationship is all about the square root of 2. Okay? Now again, this work looks confusing. By the time you get really good at it, you can just be like, oh, hey, if I have 10, divide by 2, tack on the square root of 2. Okay? For instance, instead of 10, let's make this, 40. If I made that 40, what would my other leg be? It would be 20 square root of 2. Divide by 2, tack on the square root of 2. Again, start recognizing the trends. It helps everything out. You don't even have to do the work. You start recognizing it, you start seeing it, it clicks, you know the answer. It's just those special little rules you have to recall. So let's try number 1 here. Find the value of x, give your answers in simplest radical form. So it's a 45, 45, 90 triangle. Recognize. I have the leg is 17, which means my hypotenuse is then 17 square root of 2. Number 2, my leg is 20. It's a 45, 45, 90 triangle, which means my hypotenuse is 22 square root of 2. All right, 3 is a tough one. Why is 3 a tough one? Because I don't have a square root of 2 with it. Man, okay. It's 45, 45, 90 triangle because the legs are the same. Does everybody see that? The legs are the same. That's the isosceles theorem. So, what am I going to do with 8 then? I'm going to divide by 2 and tack on the, and I get 4 square root of 2. Good? Okay. Number 4. Great. Now I see the square root of 2. That's my hypotenuse. What's my leg going to be? Just 25. And again, what's the relationship with 45, 45, 90 triangles? It's all about the square root of 2. 45, 45, 90 triangle is all about the square root of 2 rule. Okay, good work. 45, 45, 90 triangles. Those are the easy triangles because which ones are tougher? The 30, 60, 90s. They're the tougher ones. Yeah, 30, 60, 90 triangles are tougher. Why? Well, now you have to remember 3 rules because there's 3 different angles, not just 2. So in a 30, 60, 90 triangle, the length of the hypotenuse is 2 multiplied by the length of the shorter leg. And the longer leg is the square root of 3 multiplied by the length of the shorter leg. So, what that means here, on a 30, 60, 90 triangle, you always want to find the shortest side first. The shortest side is always the easiest to manipulate from there. Why? Because the hypotenuse is just double that. Okay? So anytime I have the short side, the hypotenuse is always twice that. So if my short side's 5, my hypotenuse is 10. If my short side is 20, my hypotenuse is 40. If my short side's 100, my hypotenuse is 200. Okay, that's always a relationship. Most people do really well in that. It's this relationship that they struggle on. The square root of 3. Okay, so the hypotenuse is 2 multiplied. The longer leg is the square root of 3 multiplied. So anytime I have the short side, the long side is then multiplied by the square root of 3. Now, how do you remember those? Well, me personally, I always think of 45, 45, 90. They share 2 angles, so it's the square root of 2. In a 30, 60, 90, there are 3 different angles, so I have the square root of 3. Okay? And that's just kind of how I recognize or those type of things. Same idea here in the next one. My short side's 11. Well, my hypotenuse is 22. My long leg is 11 square root of 3. Again, on your test, they will give you a reference sheet that looks just like this. You'll have x, 2x, and x squared 3, so you can visibly see the relationships. But again, it's problems like this. What happens if they give me that long side where it's 12? Okay, if they give me 12, what's my relationship with the long side and the short side? I don't want to divide by 2 now. Now I want to divide by... Yeah, divide by 3. So now I get 4 square root of 3. And then anytime I have that short side, again, I always want to find that short side first, because then you can always find every other side, and I double it, and I get 8 square root of 3. Okay? Let's try a couple here. This is number 5. Again, every time I do this, I want to find the short side first. If I have the short side, it's all great from there. But anytime I do this, I want to find the short side. In number 5, what am I given? Am I given the short side, the long side, or the hypotenuse? I'm given the hypotenuse. So what's the relationship between the hypotenuse and the short side? The short side is 9, because the hypotenuse is double the short side, or the short side is half the hypotenuse. Now that I have 9, what's my long side going to be? 9 square root of 3. Okay? So it's all about that rule of the square root of 3. What about number 6? What am I given on number 6? I'm given the short side. Well, let's find the hypotenuse first, because that's always the easiest one. Hypotenuse has to be 4. Nice job, because I double it. And then I find the long side. Long side is going to be 2 square root of 3. Okay? And again, 30, 60, 90 triangles have 3 rules. 45, 45, 90s have 2 rules. Number 7. What am I given on number 7? I'm given the hypotenuse. I always want to find the what side first? Well, what's the relationship between long side and short side? Half. Okay? So what's half of the hypotenuse? What's half of 24? I get 12 square root of 3. Okay? Now that I have that, now I can go to my long side, and my long side is 36. And how do we get 36? We take 12 square root of 3 times the square root of 3, which really gets me 12 square root of 9. And we all know the square root of 9 is 3. 12 times 3 is 36. Recognize that. Okay. What about number 8? Number 8 is the tough one. Number 8 is probably the toughest ones you'll see. Okay. They give me the long side is 33. What do I want to find first always? Find the... Okay. What's the relationship with the long side and the short side? So short side is square root of 3, right? So technically I want to divide by the square root of 3. But again, we don't like a radical in the denominator, right? So we multiply by the square root of 3 over the square root of 3, which gets me 33 square root of 3 over square root of 3 times square root of 3 is the square root of 9. Square root of 9 is 3. So I get 11 square root of 3. And now that I have the short side, now how do you find the hypotenuse? You double it, and you get 22 square root of 3. Okay? Number 8's the tough ones, okay? Because that's the one where you have to remember, again, once you get really good at it, you start recognizing, oh, I just divide by 3 and tack on square root of 3. It's just like the 45, 45, 90s. The only difference is square root of 3 instead of square root of 2. Um, 9, 10, 11 here. Take a couple seconds, try these three. Change the gears back to the 45, 45, 90s. Okay, and take a couple seconds, try these three. All right, Mark, what are you thinking? Number 9. 2 square root of 2, nice job. Because 45, 45, 90 triangle is all about what rule? It's the square root of 2. What about number 10? I'm given the hypotenuse now. Now I want to find the legs. What are the legs going to be, Shane? It's not 2 because it's actually 4. Right? Because that's when you just divide by the square root of 2. Well, it already has the square root of 2, so I just cut it off basically. And it's 4, right? Number 11. Now, what makes number 11 really easy here, Andy? Yeah, it's a 45, 90, 45, 90. It has to be 10. The other side's 10. That one's kind of a gimme, wasn't it? All right, same idea. Now change the gears back to the 30, 60, 90 triangles. Okay, try both of these. Again, square or 30, 60, 90 triangle again is multiplied by the square root of 2 or multiplied by the square root of 3. Remember the different rules. All right, Phil, what did you get for number 12? You find x first, hopefully, right? X is 4, which means y is 4 square root of 3. Nice job. Again, the relationship there is half. Then take that one times the square root of 2. And you get what? Number 11. Notice, what do I have? I have the long side. When I have the long side, I still want to find the what first? Short side. What's x going to be, Sean?
Short side.
Yeah.
That would be...
Short side is? How do you get from long side to short side? It's all about the what? Square root of 3. There already is a square root of 3, so you just... And what do you get for x then? X is 7. And then once I have the short side, I find the hypotenuse, and the hypotenuse is? 14. Nice job. Okay. Now, using all of that information, try these 4. Now you have 45, 45, 90s, and 36, 90s all in the same. Take a couple seconds to try these 4. So number 14 tells me it's a 45, 45, 90. The leg is 8 square root of 2, which means the hypotenuse is what, John? The hypotenuse is 16. Nice job. So I would take 8 square root of 2 times the square root of 2, which is 8 square root of 4, which is 8 times 2, which is 16. Number 15. You have the short side, long side hypotenuse. You have the... Gosh, life is easy when you have the short side. Because the hypotenuse is then... Hypotenuse is 20 square root of 3 because I double it. And then my long side is 30. So I would take 10 square root of 3 times by the square root of 3, which is 10 times square root of 9. 10 times 3, which is 30. 16. It gives me the what, Jack?
16.
So the leg is? 2. 17. Toughest one out there, 17. When they give you that pesky long side and it doesn't have anything to do with the square root of 3. So that means you have to do what, Monahan? Yep. So I take 12 divided by the square root of 3. However, we don't want radicals in the denominator, right? So I multiply by the square root of 3 over the square root of 3, which really gets me 12 square root of 3 over 3, not 2. And 12 divided by 3 is?
4.
So I get 4 square root of 3. Which then means, what is my y value? My y value is? Anybody? 8 square root of 3. Because my hypotenuse is always double my short side, right? Good work. Nice job. And there's your assignment.